Good evening, dear viewers. I have started to explain this YouTube channel mainly for the plus 2 students. I am much interested with basic organic chemistry. Plus 2 students they have to make themselves free in mind to start reading chemistry, physics and biology. Especially when you are reading chemistry, full attention is required along with rough notebook and pencil in your hand. Today's video is based on haloalkanes. So before starting my session of haloalkanes, I'll just explain you what is alkanes and what is halogens. So alkanes are linear chain compounds. Alkanes are single bonded compounds where we will call as ethane, methane, pentane, butane, propane. What are called halogens? Chlorine, fluorine, bromine, iodine. So these elements are said to be halogens, and ethane, propane, butane, pentane are said to be alkanes. So they are all linear chains, no double bond between them. Only carbon and hydrogen are bonded between one atom to the other. So coming to the point of haloalkanes and haloarenes classification. Alkanes deals with the aliphatic compounds where you don't have any ring in the structure. You will be having a linear structure. So next class I will be explaining you with the structures with my board and chalk talk. Chalk and board talk I plan to explain to all my viewers. This video is just a basic of what is haloalkanes and what is haloarenes. Students, kindly understand that arenes means they are aromatic compounds. They are ring structures. They have bond, ring inside bond. So benzene is basically present. Along with benzene, one halogen is present. So para chlorobenzene, ortho bromobenzene. So it goes on. Whatever the substitution, we all know that a benzene ring is having various orientation. So what is called orientation? Para position, ortho position, meta position is called orientation. Orientation means direction. How we are talking about sun rises in the east, sun sets in the west. So based on the direction where it starts and where it sets, we are saying likewise. When an atom is attached with the first position, second position, third position, we are calling them as orientations. And the substitution in these orientations are said to be ortho position, para position, meta position. So each benzene ring, each aromatic structure is having two ortho, two para and two meta positions. So first position is said to be the para, ortho, meta. Again para, ortho, meta. So opposite they have the same orientation within them. Now coming to the point of haloalkanes. So first two structures we are going to study. One is called haloalkanes, the other is said to be haloarenes. Haloalkanes, linear chain compounds, haloarenes, aromatic compounds along with halogens. So on the basic number of the halogens, we know chlorine, bromine and iodine. In that, monoalkanes, dihaloalkanes, trihaloalkanes we are going to study. What is called mono? We all know that mono means single. What is called di? We all know that di means two. What is called tri? Tri means three. So mono haloalkane means enna abdina? Mono means single, halogen is attached with the linear chain compounds. So it is said to be mono haloalkane. Example is chloroethane. So what is the formula for ethane, students? C2H6 is the formula for ethane. When you remove one hydrogen and substitute one halogen, it is called as ethyl chloride. The structure is said to be monohaloalkanes. So it is said to be monohaloalkane. Now coming for dihaloalkane. It indicates what? Two halogens are substituted to the given structure. What is two halogens? So two hydrogens are replaced and they are going to be added with two halogens. Then similarly, what is called tri? Three halogens are substituted instead of three hydrogens. So you have three carbon atoms. Each carbon atom is bonded with two hydrogen atoms, and beside them they have two more hydrogen atom attached to that. In the removal of three hydrogens and adding three halogens, then it is said to be trihaloalkanes. So chlorine is attached, it is said to be trichloroalkane. Bromine is attached, it is said to be tribromoalkane. So it goes on. So coming to the arenes, like that classification of arenes, monohaloarene, dihaloarene and trihaloarene. So what is called monohaloarene? You have one halogens in the place of aromatic ring structure. What is the formula for benzene? Students, clear? Benzene is an aromatic structure. The molecular formula is C6H6. Now you are going to replace one of the hydrogen with the halogen, then it is said to be monohaloarene. So chlorobenzene. You are going to replace two hydrogens from the benzene and you are going to add two halogen atoms, then it is said to be which position you are going to give numbering 1, 2, 3, 4, 5, 6. So you are going to give 6 numbers. So it is said to be 1, 2 dichloroarene. So it is said to be dihaloarene. If 3 hydrogen are replaced with the halogen atoms, then it is said to be dihaloarenes. So monohalo compounds are further classified according to the hybridization of the carbon atom with the halogens to whom they are bonded with. Now coming to the alkyl halide or haloalkanes. So what is called alkyl halide? So you all know that alkyl halide is nothing but they have halogens present in the alkane structure. For example, when you take a methane, in that CH4 is the formula. You are replacing one hydrogen with halogen, then it is said to be primary. If you are replacing two hydrogens with two alkyl group and one halogen, then it is said to be secondary alkyl halide. If you are going to replace 3 hydrogen with 3 alkyl group, then it is said to be tertiary trialkyl or tertiary alkyl halide. So how many hydrogens you are going to replace with the alkanes, then based on that you are going to classify them as primary, secondary and tertiary. Allylic halide, what is called benzylic halide, what is called allylic halide. We all should be aware that what is called arene, what is called alkyl, what is called allyl. Allyl is nothing but you don't have any aromatic structure or you don't have any aliphatic structure. When you have a carbon atom, beside the carbon atom you have one more double bond present, then it is said to be the allenes. So alternative positions you have double bond between the aliphatic linear structures or aromatic structures. If you have a single bond followed by double bond, or if you have only one double bond and one single bond, then the structure is said to be allylic halide. So alkyl halide, allylic halide, benzylic halide are classical examples of your monohalogen compounds. Compounds containing sp2CX bonds. What is called sp2CX bonds, which is said to be vinylic halide. Arylic halide is said to be called as vinylic halide. So it is also called as vinylic halide. The carbon atom which bears a partial positive charge, where the halogen atom bears a partial negative charge. So coming to the nomenclature part of your haloalkanes, you have a carbon atom and the carbon atom is attached with the hydrogen as well as the halogen. We all know that halogen is an electronegative element, so it always bears a charge called negative, and the carbon atom, which is an electropositive element, and bears a charge called electropositive. So halogen bears an electronegative element, carbon bears an electropositive element. So this is one of the basic nomenclature involved in your haloalkanes. Coming to the method of preparation. So we studied what is haloalkanes, what is allyl halogens, what is aryl halides. Coming to the nomenclature, we have studied that carbon atom is an electropositive element, so it bears electropositive charge over them, and the halogens are electronegative elements and it bears electronegative charge over them. Coming to the method of preparation. The hydroxyl group of the alcohol is replaced by the halogen on the reaction in the presence of concentrated halogen acids or phosphorus halides. Two products are escapable. Other two products are escapable gases. The reaction will be, we are taking alcohol. What is the formula for alcohol, students? You have any OH group in the given alkanes or aromatic structure, then the structure is said to be alcohol derivative. So you take an alcohol, react the alcohol with the hydrogen halide. So any hydrogen halide, give example for the hydrogen halide is H is a hydrogen and halide is chlorine, hydrochloric acid. So you are going to treat alcohol with hydrochloric acid. Automatically in the presence of zinc chloride, which is acting as a catalyst, the OH group which is present in the alcohol and hydrogen which is present in the hydrogen chloride react to give a water. So the removal of water molecule takes place, thereby it forms the haloalkanes. So haloalkanes are nothing but halogen with the alkane. So one of the basic preparation is taking a primary alcohol, reacting the primary alcohol with the hydrogen halide in the presence of zinc chloride, which is acting as a catalyst to form alkyl halide. So this alkanes removal of water will give you one of the best method for the preparation. And the other method I will say you, very easiest method. They will ask you write any two methods involved in the preparation of haloalkanes. Second one, take primary alcohol, treat the primary alcohol with phosphorus pentachloride. There will be forming the RCl group with the removal of H3PO3 group, phosphorus chloride will be formed. So that is phosphoric acid will be removed. There will be formation of the alkyl halide. So you can treat alcohol with phosphorus pentachloride. There will be forming an haloalkanes with the removal of phosphoric acid, H3PO3, which is said to be the phosphoric acid. So two methods are possible. One is primary alcohol with hydrogen halide, then taking a primary alcohol or tertiary alcohol, treating with phosphorus pentachloride, there will be formation of haloalkanes. So next video I will be explaining you regarding the order of reactivity of alcohol with the halo acids, that is which is greater, tertiary, secondary, primary, how they are said to be greater. Thank you students. Tomorrow I will be posting you the next video based on the order of reactivity of alcohol with the halo acids. Thank you everybody.